Alright, welcome to my review video for the end of Math 172. I'm going to kind of pick up where we left off in class on Wednesday. I'm just going to go through some of the problems from your review to help you prepare for your exam on Monday. So the first one I'm going to look at, it says solve the triangle shown to the right. Alright, so we've got, hopefully you can see this. This is just a printout directly from my math lab, so these are some variation of the same problems that you're working on. You can see I have angle A, angle B, angle C, and then I've got side lengths of 9, 9, 11. So we're asked to determine all of the angle measurements. So please excuse the noises in the background. The children are home from school today, and they are in their rooms, cleaning rooms, and complaining about having to work. So anyway, I apologize for the noise. In this problem, so we're going to solve the triangle, and we have three side lengths, but we have no angle measures. So what we need to do is, if we go to the law of cosines, we can find one of the missing angles given these three sides. So we know from law of cosines, and by the way, you will have a formula sheet on the exam. I've already posted it in Blackboard. But this is what it looks like. So if you want to scan through that and find the formula that you need, we're going to use law of cosines, and law of cosines is bottom right corner down here, and we're going to be using one of these variations. They're really all the same thing, but they're just given in terms of different angles. So you're not going to need this Heron's area formula for the exam, I don't think. But we're going to use the law of cosines. So let's say I want to find side length, let's say I want to find angle A. To find angle A, I need to start with side A. I know that I need to do A square, and I'm going to have to zoom out a little bit. I promise the children are not being abused. They're just being made to clean up their rooms, and they don't like it. Okay, so A square equals B square plus C square minus 2 times B times C times cosine of angle A. So this is the version, since we're going to solve for angle A, I need angle A here. So A, side length A is opposite angle A, so we'll put in 11 for lowercase a. And then side length B is opposite angle B, so that one's 9. Side length C is 9, it's opposite angle C. And then we have minus 2 times B times C times cosine A. So we've got all the side lengths in, and we can solve for angle A. So 11 squared, that's 121. And then we have 81 plus 81, which is, what's that? 162. And then 2 times 81, that's 162 again. Times cosine of A. Okay. Then working through the calculations, I can subtract 162 on both sides. So 121 minus 162 gives me negative 41 equals negative 162 cosine A. Divide both sides by negative 162. Okay, and then that gives me this long decimal, or I can just write it as a fraction, 41 over 162 equals cosine A. Now I need to take cosine inverse of this result here. So just typing it straight into the calculator, I'm going to say second cosine to get my inverse function, and then I'm going to put in the 41 over 162, close parentheses. I'm getting 75.3 for A. 75.3, and how do they said round to the nearest tenth. So we've got 75.3 that goes in for A. Okay. To get angle B, you can do the same formula again if you want to, just solving it for angle B. Or because you've got angle A, you can write that in. And now you can use law of sines, which, oh, I'm sorry, there it is. I just wrote it in. Now I can do law of sines. That's faster. So law of sines says I can do side length A, 11, over sine of angle A, which was 75.3, equals, and then let's say I want to find angle B, so I'll do side length B, which is 9 over sine B. So this is a little bit easier to work with. Law of sines goes a little bit easier. So cross multiply, 11 times sine B equals 9 times sine of 75.3. Divide both sides by 11. And now do sine inverse of both sides. So you get B equals sine inverse of all this stuff. So on the calculator, I'm going to go second sine inverse. I'm going to, you know what? I'm not going to do that. I'm going to type all that in first. Let's type in 9 times sine 75.3. Make sure your calculator is set to degrees for this problem. So 9, let's see, we're going to do sine of 75.3. Okay, enter. I need to multiply by 9. Then I need to divide by 11. Okay, I'm going to keep that number right there. I'm not going to clear anything out. And I'm going to go, I need sine inverse of this. So I need to go second sine, and then I can go second answer, which is down here on the, all the way at the bottom. This button right here. Second negative key, that gets you to answer. So that'll just put in the same information that you just did. Sine inverse of second answer, enter, and we get 52.3 rounding to the nearest tenth. 52.3. Okay, be careful on this problem. If you see this on the exam, B and C have to be the same number because the side length B and side length C are the same number. It is possible, because this has happened to me when I was working through this particular problem, that if I did 180 minus A minus B, this answer had a different decimal and it was marked wrong. So be careful with this one. Let me see what happens. If I do 180 minus 75.3 minus 52.3, I'm getting 52.4. My math lab will count that wrong if you enter 52.4 because it's supposed to be the same thing as angle B. So I apologize about that. That's just a rounding issue. So if you see this problem on the exam, whatever number that you get here, you're going to have the same number here. Hopefully you'll have the correct number. So you'll put 52.3 so that these two will be the same. Okay. Alright, so that's that one. Let's move on to the next one. We're going to use the parallelogram rule to find the magnitude of the resultant for the two forces shown in the figure. Okay, so I'm going to turn this, these two vectors that you have here, we're going to turn this into a parallelogram. So we're going to draw a parallel vector over here and a parallel vector over there. And these lengths, this one is going to be the same as that one, so that's going to be 18, and then the top one is 6. Okay, the angle here is 30, so we can get the remaining angles for the parallelogram. We know there's a total of 360 degrees in the whole thing. The angle over here is also 30 degrees, and then 360 minus 30 minus 30, that's 300. And then divide 300 in half. So you put 150 here, 150 here. Okay? The magnitude is going to be the length of the resultant. The resultant, if you recall, is the it would be the vector that you get by adding these two together, and it's also going to be the vector that goes from this point all the way down to this point. Okay, so what you're doing is finding the length of this diagonal. Now, how can we do that? Well, we currently have this angle, and we have these two sides. So because we've got side, angle, side, that means that we can go to law of cosines to get the length of the diagonal up here. I'm going to call that side x. Okay, I hope you can see that. So this is what I currently have. Okay, I've got to find the length of this side x. To do that, I'm going to go to the law of cosines. Alright, so to get this side length, I need to use, I would need to use cosine of 150, and then 6 and 18 can go in from my a and my b in the law of cosines formula. So it's going to be x squared equals, I can call this a, so I can do 6 squared. I can call this side b, so 18 squared minus 2 times a, which is 6, times b, which is 18, times cosine of 150 degrees. Okay, so if you need to, pause and make sure you've know where everything's coming from. We're using law of cosine so that we can get this side length over here. And once we solve this for x, we'll have our answer. If you want to type all this directly into the calculator, there's nothing wrong with that. I would encourage you to be careful because you've got so much going on here. I'm going to write this as 36 plus, what is 18 squared? That is 324 minus 2 times 6 is 12, and 12 times 18 gives me 216 times cosine of 150. Okay. Alright, now I'm just going to type it straight in. So I'm going to say 36. Let's see if I can get this up here where you can see it. There's 36 plus 324 minus 216 times cosine 150, close parentheses. Okay, I get this 547.06 number, but I need to take the square root to get x. So second square root, second answer, enter. I get 23.389, and I think they say round to the nearest tenth, so we'll go with 23.4. So 23.4 is our answer. Okay, so that's how that type of problem is going to work for you. All right, next one. Okay, this time we're doing a dot product. We're using vectors. We're given vector u, it is 3, negative 4. Vector v is 5, 1. Vector w is 1, 3. And we have to evaluate 4u dot v. So 4u is going to be, you just multiply everything inside vector u by 4. So it's going to be, you can think of it as 4 times the product, or times the vector 3, negative 1. And then just multiply the inside by 4. So that gives you vector 12, negative 4. So we have to do 12, negative 4 dot vector v 5, 1. Okay, when you do a dot product, your final answer is just going to be a single number. The way it works is you're going to do a times c, so 12 times 5, plus b times d, negative 4 times 1. So 12 times 5 is 60, and then that's going to be negative 4. 60 minus 4 gives me 56 for my answer. Okay, so that's how your dot product works. Next number. We have to, we're given a complex number on the graph. So remember, the x-axis is your real part, the y-axis represents the imaginary part. So it ends right here at this point. Now I know that you probably can't see this too well and you can't really blow it up, but it appears to be at -4. The best I can tell, it might be at -5. Yeah, it's actually at -5 on the imaginary axis is where the vector stops. Okay, so this is the ordered pair, or this is 0, -5 if you think of it in terms of an xy coordinate. So that means your real part is 0. So you have 0 plus -5 times your imaginary part, I. So 0 plus -5i is going to give us -5i for the rectangular form, because you're writing it in the a plus bi form. Then you have to determine the polar form. Alright, so this is not hard to do. You have to remember though, it's going to be cosine, it's r, if I can find a space to write it on here, is r parentheses cosine plus I times sine. So you have to remember that's the way it needs to be written. R is the square root of, you can think of it as x squared plus y squared. So your x was 0, plus your b, or your y, was -5. Okay, so I'm going to have to zoom out a little bit. So that gives us the square root of 5 squared, which is 5. So r equals 5. And then we have to put it in the one that says cosine plus I times sine. So it's got to be d, and so we're going to go with d. R is 5. Alright, then we have to get our angles for cosine and sine. Well, remember, if you start over here, to get all the way around to there, that's going to be how many degrees? That's 270 degrees. So 270, 270, and that's it. In this problem, it says find the equation of an ellipse satisfying the given conditions. We have foci at -2, 0 and 2, 0. Length of the major axis is 10, and we have to give the equation for the ellipse. I would start with a picture. We have foci at -2, 0 and +2, 0. The length of the, remember, foci always fall on the major axis. The length of our major axis is 10. So that means it's going to go 5. Well, first of all, the center of the ellipse is halfway between the two foci, and so that puts the center at the origin. If the length of the major axis is 10, that means it's going to be 5 on this side, 5 on this side, and we've already got 2, so we're going to go 3 more out. So that puts us at +5, and then this was at +2, -2, -5. So these are the vertices of our ellipse. So it's like this, something like this. We just got to figure out how high or low it needs to go. And to do that, you're going to use the formula c squared equals a squared minus b squared. Okay, c is the distance from the origin to one focus, which is 2. So you can put 2 squared for c. A is the distance from the origin to the vertex, so that would be 5. So we have 4 equals 25 minus b squared. So that makes b squared equal to 21. So with that information, if b squared equals 21, you can continue. You can draw it. Square root of 21. What's that? Square root of 21 is about 4.5. So you can draw that up here if you want to and finish it out. But the actual sketch is not required. We have to give the equation for the ellipse. So if you recall, your equation is going to go x squared over a squared for the ones that are the major axis is horizontal. It's x squared over a squared plus y squared over b squared equals 1. So we can just substitute in. Now we're going to get y equals, make sure when you type this in that you remember to type y equals x squared over a squared was 25 plus, you know what, I'm sorry, take it, no, we're not going to put y equals, that's for another problem. On this one, you're going to say x squared over 25 plus y squared over b squared was 21. And they're all going to be equal to 1 when they're in this form. X squared over 25 plus y squared over 21 equals 1. And that's it. Alright, so I hope you're finding that helpful. Going on to the next one. This problem says determine the type of conic section represented by the equation 2x squared plus 4x plus 2y squared minus 16y equal 38 and graph it. Okay, now finding the conic section represented by that equation is easy if you can just remember that if you have both an x squared and a y squared term, that means you either have a circle, a hyperbola, or an ellipse. So those are our choices. If they have the same coefficients on the x squared and the y squared, and they're both positive, it's going to be a circle. So it's a circle. If you had different coefficients on these two, it would be an ellipse, and if you had opposite signs, it would be a hyperbola. But this one's going to be a circle. Then we have to graph it. So that means we have to find the center and the radius. So we have to find the center and radius. To do that, we have to complete the square to get it into that standard form. So our goal is to write it as x minus h quantity square plus y minus k quantity square equal r square. So we can do that if we group the x's together. So I'm going to do 2x squared plus 4x. I'm going to put a plus blank after it because you know what, I don't need that yet. Never mind. Plus 2y squared minus 16y equal 38. Okay, looking at the first two terms, we need to factor out, we got to have a leading coefficient of 1, so we're going to factor out a 2, and that leaves x squared plus 2x. Here I'm going to put plus blank, because I'm going to have to add a number to that as well. Plus, let's see, I've got too many pluses here. Alright, so here I need to factor out the 2. So that my y squared has a leading coefficient of 1. That's going to give me y squared minus 8y. I'm going to put another plus blank here. And then on the other side I've got my constant 38. And because I'm adding to the left, I'm going to also add to the right. Plus blank, plus blank. Okay, now, what number goes in this blank? You're going to take half of 2. That gives you 1. And if you square 1, that's going to be 1. Over here, take half of negative 8, that gives you negative 4, and if I square negative 4, I get 16. Now that goes here. For the right side, be extra careful. You don't automatically just put the same numbers in these blanks, because when you put 1 here, you really added 2 times 1. So 2 times 1 gives me 2 there. And then over here, when I put in the 16 inside, I really added 2 times 16, which is 32. So that goes here. Now I can write this as 2 times, alright, if I factor that, it would give me x plus 1 times x plus 1, or x plus 1 quantity square, plus 2, and the 1 is what this number always matches what you got when you first took half of that middle term. Half of 2 gave me 1, so the 1 goes here. Over here, half of negative 8 gave me negative 4, so I'm going to have parentheses y minus 4 quantity square. On the other side, 38 plus 2, that's 40. 40 plus 32 gives me 72. To get it into the form that I need up here, I'm going to divide both sides of this by 2. So dividing everything by 2 all the way across gives me x plus 1 quantity square plus y minus 4 quantity square equal 36. I don't know if any of you saw that video that went viral with this guy on the BBC giving an interview and his children come into the room. That's very much like our life here.